Okay, in this video we're going to be looking at a function of x, and we want to be able to solve it. The function in question is p of x is equal to x cubed take away 5x take away 1. Now, as we've seen in class, the actual formula for a cubic can be very difficult to use, and you're not meant to remember it. Okay, so don't worry about that. So we've got to find another way of figuring out how to solve it. And one way is by substitution, in which we just substitute values into the expression and see what we get. Okay, so I've set up a table already from -3 up to 3. Okay, and we're going to look at this table first to determine what is actually happening for the graph, and then we're going to plot the graph and see what the actual function looks like. Okay, so the first and easiest one to deal with will be x is 0. When x is 0, we get 0 take away 0 take away 1. So when x is 0, p of x is -1. Now when x is 1, you get 1 cubed, which is 1, take away 5, which is -4, take away 1, which is -5. When x is -1, we get -1 plus 5, which is 4, take away 1 is 3. Okay. When x is 2, you get 8, take away 10 is -2, take away 1 is -3. When x is -2, you get -8 plus 10, which is 2, take away 1 is -1. Sorry, well, let me just check that again. -1 plus 5 is 4, take away 1 is... No, I'm looking at the wrong one again. Sorry, we've got -2 cubed is -8 plus 10 gets me the 2, take away 1 is 1, not my -2. I had a sneaky suspicion something had gone wrong there. Okay, always good to check your results. When x is 3, we get 27 take away 15 take away 1, which is 11. Okay. And when x is -3, we get -27 plus 15 take away 1, which is -13. Okay. So we have a series of values for x and a series of values for p of x. Now what you need to notice is that p of x is negative and then positive here, which means that if we're going from a negative to a positive, we are actually crossing the x-axis. Between -3 and -2, we must be crossing the x-axis. So, in other words, there is a solution between -3 and -2. Likewise here, between -1 and 0, we go from positive to negative. So we go from above the x-axis to below it. Okay, so there must be a solution there also. If we have a look at 2 to 3, we're going from a -3, to a +11. Okay, so we are crossing the x-axis there as well. So there are 3 crossing points. Now if we plot these points, we've got -3, 13, -13, which is down here. We've got -2, 1, which is here. -1, 3, which is here. 0, -1. 1, -5. 2, -3. And 3, 11. Just all the way up here. So I'm going to do my best to draw a curved line that goes through all points here. So Excuse if it's not quite as accurate. Oh, this isn't going too badly though. Missed that one. Okay, so there is my attempt at graphing this function. And we can see, as described by the table of values, going from a negative to a positive or positive to a negative, that the line crosses the x-axis here, here, and here. Okay, so we would be able to narrow and refine our result. So say if I wanted to home in on this coordinate specifically between x is 2 and x is 3, then I would probably put in x is 2.5, see if it was positive or negative. Positive would mean I would need to move closer, okay, to 2. If it was negative, then I would need to move closer to 3 in order to exactly get to p of x is equal to 0. And that is one way to numerically solve a cubic.